Hi everyone, it's Miss Cox. I thought that I would just help a little bit with these balancing chemical equations. So here I have a gizmo on my screen and I'll share the link to everybody and hopefully you can figure out how to log into it. If not, send me an email, I'll make another video. So the whole point of balancing chemical equations is if you remember that thing that we talked about in science class where our masses have to be the same at the beginning and the end of the equation. So remember, things can't be created or destroyed. So whatever we start with, we kind of have to end with. So here, we call that the conservation of mass theory. So here, if you remember, so if I have my equation and I'm making water, and I think we did this example in class, there's certain molecules like hydrogen and oxygen which are diatomic. And remember, diatomic means that they have to happen in pairs. So I can't ever just see this hydrogen by itself. I can't ever just see this oxygen by itself. They get too lonely, so they need a friend. So they're the care bears of elements. They need to hold that sharing bond all the time. So we see them in pairs. So that's why I have H2 and O2. Remember, those diatomic molecules include hydrogen, but then they start at 7 on the periodic table and they make a 7 down to iodine. Okay, so you go across to chlorine and go down to iodine. So those are my diatomic molecules. So if I'm looking here, and again, this is just in my gizmo, and I'm making that water, I can see that there is a problem here. I can see right here that there's a problem. Okay. I, for instance, have 2 molecules of hydrogen here because it's H2. I have 2 molecules of oxygen here because it's O2, but I only have 1 molecule of oxygen in my water. So, and if I'm looking at this here, I can see that as well. If this is my hydrogen, so my hydrogen's right here, I count 1, 2. My oxygen's right here, I count 1, 2. But if I'm over here, I can see my 2 little white guys, those are my hydrogens, and only 1 red oxygen. So that's a problem. This is not balanced right now. But this is how we often think of chemistry. We know that we put hydrogen and oxygen together, and we know that at the end, the formula for water is H2O. But how do we actually get there? And so there were some rules, if you recall. One of the rules that we had was that you cannot change your subscript. So any of these little subscript guys that are here, right here, okay, any of these guys right here, the little numbers, I can't change those. I can change my coefficients, which are the main big numbers in front of my element. So I'm never going to touch the tiny numbers. Remember, awesome things happen in small packages, just like your teacher. So I'm never going to touch those tiny numbers. I can only change the big numbers. Okay. So if I'm looking at this, the only way that I can try to get any type of balance here is to change my big numbers. Now, I'm going to look across and we're going to compare these, and I'm going to show you a separate way in a second. I have 2 hydrogens here. I have 2 hydrogens right here. I'm happy with that. I have 2 oxygens here. I only have 1 here. I am not okay with that. So the first thing I'm going to do is change this coefficient to a 2. And now look, so I have 2 oxygens. Those match, science smiley face. But now I have 1, 2, 3, 4 hydrogens. Those don't match. I'm not happy with that. So I'm going to go back to this coefficient, erase it, and write a 2. And if you look, now everything is balanced. So the other thing that I can do in this chemical equation gizmo is I can show these histograms. So I can show my numerical values. So all of my oxygens are going to be my reds. All of my hydrogens are going to be my whites. Let's just ignore Miss Atkinson for right now. She's giving me a funny little story. So all of these are right here underneath, and it shows me that these are balanced. Now let's just see if this goes kind of out of whack here. So see how now before in my products, or sorry, in my reactants, remember these are all called my reactants, these are called my products. So in my before, my reactants, now I have 12 because I just put in a 6 here. And afterwards I have a 4. They don't match. I want these numbers to match. Okay, so do you see how they're all even steel here? They're super, super even. We're good here. Okay, so these are some ways that you can do this. And if you're doing here, you can show the summary. It's going to show you that they're balanced. And you can go through and you can kind of click through these different types of reactions that we haven't really talked about yet. But the goal here, you don't need to know these yet. These words, single replacement, decomposition, double replacement, combustion. We've talked a little bit about them, but not a lot. What you're going to do here, though, is you're going to click through, and I want you to try to balance these equations. Okay? So again, this is how we do it. So if I'm looking at this single replacement, what this means is that I start with aluminum here. I have aluminum and I have hydrochloric acid. And what's happening is that my aluminum and my chlorine are coming together here, and it's displacing my hydrogen. It's bouncing that out. Okay, so that's what we call here. And I want you guys just to try to go through and balance these so that you have the same amount of atoms on both sides of the equation. So just to summarize, remember that we cannot change our subscripts. So those little tiny numbers, they're epic on their own. We're not going to touch those. Our big numbers in front, our coefficients, those we can change. So that's what we're going to fool around with here. And it's great in this gizmo because you can actually just click on the number, erase them, and replace them and see what you have. And if you want, you can show histograms here. There's a little package that I'm going to upload, some practicing that we can do. So I'll upload those. If you need more help, send me an email. But I think that this is the easiest way of doing it right now. Just click and see. Some of them are going to be really frustrating. So some of them you're going to have to change a lot of, and that's what I was trying to tell you guys in class, is that you might have to go back and forth a couple of times before this works, and that is okay. So you're always comparing the left side of the reaction to the right side, and that you have the same amount of each molecule. So I want the same amount of aluminums on both sides, I want the same amount of chlorines on both sides, and I definitely want the same amount of hydrogens on both sides. Okay? Let me know how it goes.